Hello everybody and welcome back. Root Gear here with more of the 2000 Pascal paper. We're up to question number 15, which says, the digits 1, 1, 2, 2, 3, and 3 are arranged to form an odd 6-digit integer. Okay. Given that we know the digits, the odd seems very important. Okay. The 1s are separated by 1 digit. The 2s are separated by 2 digits, and the 3s are separated by 3 digits. What are the last 3 digits of this integer? That's a good question. Alright, and actually, it brings to mind a concept that I saw on an excellent British math program called, what was it? I think it was called School of Hard Sums. It's sort of a math, vaguely, very tinily comedy show. It's by an Irish comedian by the name of Dara O'Brien. If you can find it, some of them are on YouTube. You can go watch them. They're pretty interesting. I've downloaded a couple, but I've never seen all of them. And it's a very excellent show where they actually try and show that math can solve everyday problems. Now, the concept that they had on this show was the idea of a Langford kebab, where you have vegetables. So you have 2 peppers and they're labeled with 1s, and you have 2 onions and they're labeled with 2s, and then you have I have no idea, 2 tomatoes and they're labeled with 3s. And the basic idea is, can you arrange them so you could put a skewer through them, make a kebab, so that the 1s were separated, it had 1 vegetable in between them, and each the 2 2s had 2 vegetables in between them, and so on. Now, does that help me solve this question? No, but it's interesting. I wonder if whoever made question number 15 knew about Langford kebabs, and that's where they came up with this. Oh well. So, if I could, for some reason, remember the solution to the Langford kebab one, this would probably be very interesting. Very quick, but it wouldn't be that interesting for you guys. So, fortunately, I don't remember what the Langford kebab looks like. I just know that this is possible, which doesn't help because obviously it's possible or we wouldn't ask the question. So let's get down to it and do some math. We know it's an odd 6-digit integer, so we're going to start with a 3 or a 1 in the units digits. So automatically we can get rid of A. You can't end in a 2 and be an odd 6-digit integer. If you're an even number, your last digit is even. If you're an odd number, your last digit is odd. So automatically A is out, and we have a choice of 3. Okay. So, what can we do? Well, one of the things we could do is take each of these possibilities in turn and see if we could complete the odd 6-digit integer. And I think that's a good way to do it. I don't often start with the solutions and try and work my way to something else. Work my way to figuring out what exactly, which one is correct. So I think I'm going to try that. So obviously A is out. Let's see if B is the right answer. Well, B, I think, said we're going to end with 1, 2, and 3. And that means we have 3 spots left over. Okay, yes, B was 1, 2, 3. All right. But because of the rules, I know that if I have a 3 here, 1, 2, 3, I'm going to have a 3 here. The 3's are separated by 3 numbers. If I have a 2 here, 1, 2, I should have a 2 here. Oh, dear. And with a 1 here, I should have 1 in between this and the other 1. So this one's definitely out. The 1, 2, and 3 are all trying to occupy the same location. So B is out. And the nice thing about that is I'm pretty sure that the last 3 digits will actually determine the number. So that's why I think going with this way is probably the best. Let's try C. I'm pretty sure C won't work, but let's see if C is the right answer. So we should have 1, 3, 1, and then we'll have 3 other spots because we're talking about the last 3 digits. Well, the 1s are fine, okay? But this 3, we need to have him 3 spaces away from another 3. So 1, 2, 3. So there the 3 goes here. And that means the 2's have to go here, but they're not separated by 2 other numbers. So this one's also not going to work. Okay. D, how about 1, 2, 1? All right. I have a better feeling about this one, but it still might not work. So 1, 2, 1 are the last 3 digits. What are the first 3 digits? Well, with this 2 here, I have to go 1, 2, there's a 2. And that means that my 3's have to go here, but they're only 1 space apart and not 3 spaces apart. Okay. So it should be E by process of elimination, but let's check. 2, 1, 3. Okay. So 2, 1, 3. 2, 1, 3. So this 3 here says that 1, 2, 3 spaces must be in between that and the other 3. This 1 here says 1 space has got to be between it and the other 1. And this 2 has to be 1, 2 away from the other 2. So E is correct. Now there was probably a way to sit down and reason, oh, the 3 can never be in this position and the 2 must always be in this position or something like that. But honestly, they gave us potential answers. We ruled out 1 right away just from the statement that it's odd. And then they fiddled around and got the other ones. Incidentally, why did they have A in there? 3, 2, 1. I bet there's a way to construct it with 3, 2, 1, but then that would be violating the odd. I think that's probably why that's there. 1, 2, the 2 would have to go there, the 1 would have to go there. Nope. You could still rule out A, never mind. But that's question number 15. I think that was a very nice little question, and like I say, if you can find it, School of Hard Sums. It's by a fantastic Irish comedian, Dara O'Brien. I think it's got 3 seasons at least, but they're British seasons, so they're only 6 episodes. But it's certainly something that you can check out, and I think it's a very interesting and exciting show.